So today we will focus on something which is called tokenization. As I told you in last class, we will try to understand the concept of tokenization and the text encoding. Okay, these are two things I'll try to tell you. Now, what is tokenization? I told you in last class, tokenization is all about splitting the sentences into smaller units. Okay, and those are called what? Tokens, right? That is the purpose of it. Like for example, I told you, if I have a sentence, AI is future. Okay. Jyoti, you want to say something? Can you hear me? Everyone can hear me?
Yeah, hi, am I audible?
You are audible. Please go ahead.
Actually, having one question, like from the previous session. So
Alright.
it's like yesterday in that transformer, you have shown, no, like we can generate the multiple output. So like with 0, 1 indexing that. So like my question, like how to note like which one is the more precise output? In case we are generating 1 to 5 output for the one particular thing, then how to know this, like this is the most perfect answer as per our text.
So that you have to analyze actually manually. You have to analyze that which one is most close to the things that you want, or this thing we will do when we will work on the agentic part, right? You asked a very good question, but you will get this answer, I guess, after 20th session. Okay, when we work on the agentic part, what we do, we will have the multiple agents like agent 1, agent 2 and agent 3, right? And we will ask each agent to generate something, right? And then when each agent will generate something, the output of each agent will give to the fourth agent, agent 4. Now this agent we will program to compare the output of each of them, okay, and then format and then generate an output which is very close to, which is most effective or most relatable,
that particular thing.
Most relatable to the expectation, right? So this kind of application we are going to create, but we'll create through agent. Here we can just generate 2 output or 3 output. Here also you can do, but here what you have to do, after generating the 2 or 3 output like this, these 2 or 3 outputs you can give it to the third, it means kind of a third model as a prompt. Like you are using this guy as a prompt right now, right? You can do what? You can use one more generator, and to that generator you can give this thing as a prompt. Not this thing as a prompt. Like suppose, okay, let me try to explain like this. What happened? This guy is generating. This particular generator is programmed to generate 2 outputs, output 1 and output 2. Now I can create one more generator, right? And to that generator, these 2 things will be given as a prompt. Okay. Output that I'm getting over here, these output can be given as a prompt to the new generator with the instruction that compare these 2 output and retrieve the most relatable output. But obviously, this particular LLM, that is your GPT-2, is not that smart enough to do the things. Again, for that purpose, we have to use more advanced LLM like GPT-4 or Gemini Flash 2.5 or 2. So those, by using those things, we can do it. We will work on such kind of application, right?
Okay. Yeah, so that's what I wanted to know. Like, I thought, is there any other like things or anything is there which we can learn with this? Okay.
There are only 2 ways. Either you can do it manually, or you can let other LLM to evaluate. Like you have to create a multi LLM application. Like one LLM is generating output, the another LLM is generating some output, then third LLM is just comparing those output and giving you the most formatted result. That is also called multi LLM application.
Okay, understood.
Right.
Thank you so much.
Right. We'll work on such kind of application.
Okay, sure.
All right. So we have over here, let's say sentence. Now in this sentence, what will be called as a token? So if this is a sentence like this, then tokens will be AI is one token, is other token, the is other token, and future is other token. Right. Now the point over here is, if these are the tokens, then how a machine will learn from this token? Like I want a machine to learn from this text. Okay. So if I want a machine to learn from this text, what I want to convert these things into the numerical form. Right. So to convert this thing into numerical form, there are certain ways. Okay. Like for example, one of the most popular ways there, bag of words. Okay, it is most simple. Okay, I'll tell you the pros and cons of it. What is the benefit of bag of words? What are the problem with the bag of words? What bag of words does? It can convert your text into the numerical form. All right. Let's say I have two sentences. Okay. Let's say I have a two sentence over here. Sentence one: I am a good cricket player. Okay. Second sentence is what? I am a bad chess player. All right. Right. Now the first sentence is what? First sentence is having a positive sentiment. Okay. Second sentence is having a negative sentiment. Alright. Now I want a machine to learn how a positive sentiment sentence looks like and how a negative sentiment sentence looks like. Okay. Here I know, but I want a machine to learn. Right. So if I want a machine to learn, I need to do what? I need to convert this whole thing into the numerical form. So to convert this thing into numerical forms, first step is what? I have to find out unique words from each of them. Like I am a good. Okay, these are what? These are all the unique words. Cricket player. Okay, player, right? Now I is already there, M is, so now we have our next unique word is bad chess. Okay, so these are the unique words we have in this whole document. Like if I have a set of document is what? Whatever the document that is containing words, like languages. So now these are the unique words. I just identified them. Now these unique words will be used to represent your document in the form of, that is called bag of word representation or BOW representation. Okay. In this thing, what happened? How many words are there? 1, 2, 3, 4, 5, 6, 7, 8 words are there, right? As there are 8 words, I'll create 8 sections over here. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's it. Okay, now here I'll just I should create it a little bit more bigger. Anyway, just a minute. Let me try to create it because we have enough space. Why I'm creating so small? Let it be like this. One, 2, 3, 4, 5, 6, 7, 8, right? And all right, that is better. Now what I do here, the first thing I'll mention, that is called token. Token are what? Are my words. Okay, like I have a token over here. I am a good cricket player and bad chess. Right. Now there will be a excuse me. There will be a first document over here. Okay, document 1. and then document 2. Right. So in the document 1, what are the words that exist? In document word 1, we have I. So I'll make it 1. Am a good cricket player. Bad and chess was not there. So this will be 0 and this will be 0. Right. In the document 2, I have I am a good is not there, cricket is not there, player is there, bad is there, and chess is there. Right. So in this way, okay, in this way, I have created a data which is structured data, which is converted into which is a numerical data. I have converted my text into the numerical form, right? And this is called what BOW representation. Okay, we can call it BOW representation, right? Now over here, next one more thing will be added like this, which will represent my target. Okay, I want what? I want that my model should learn about positive and negative sentiment. I want my machine learning model should learn about a positive and negative sentiment. So that in future, if any positive sentiment sentence given to it, it can identify it as a positive sentiment. If any negative sentiment sentence given to it, it can identify it as a negative sentiment. Now this will be labeled as what 1, and this will be labeled as what 0. Right. So it means what? Here we had converted, there can be a third sentence as well. Okay, fourth sentence. So if I have suppose 100 unique words, okay, in my complete data, if I have 100 unique words, then I will have 100 columns. Okay, each column will represent one word. Okay, each column will represent what? Over here, one word. Right. And then based on the document, it will be given 1 or 0. Right. If in any sentence, one word is repeated for 2 times, suppose here good is there present for 2 times, so it will get 2. But if it is there for just 1 time, it will be just 1. All right. So here it is just a representation of each row will become a feature vector, and then for that thing can be used for the machine learning purpose. All right. So if you want to use it, you want to do it in the code. Okay, here is a theoretical explanation. It means what? If I would be given any kind of text data, right? Like for example, as I told you, but suppose if let's say if I will not have this thing, I am bad chess. I'll not write. Suppose I am bad chess player. Okay, I am bad chess. This much is written. Then what happened? Then this will be 0 over here, because A is not present in the second sentence. Again, I is present, M is present, bad is present, chess is present, player is present. In this way, we have created a document. We just converted our document to numerical form. Each document had been given a label as 1 or 0. Now, this data is what is a feature, okay, and this is what label. Now a machine learning will try to, during the process of machine learning, the algorithm will try to find out the best relation between feature and label. Okay, during the training process, the machine learning algorithm will try to find out best relation between feature and label, and based on that particular relation, in future, whenever you give any sentence, the sentiment will be identified as 0 or 1. Okay. So if I want to use it, that means if I want to implement it in Python, then how can we implement it? That means how can we do this kind of encoding? It's very simple to do actually. I'll show you, just few line of codes are there. You don't have to do anything. Okay, libraries are there to do it. Okay, you just need the knowledge of those libraries. All right. So let's say I have 2 documents, right? I just write it over here. Let's say document is equals to, okay, let's say I am a good cricket player. All right. Second was like I am bad chess layer. All right. Okay. This is a document. Okay, this document I have to convert into numerical form. Right. So to convert this document into numerical form, I need a library. The library name is what? Okay, let me first print the document only. Print document. Let it be printed first and then after fine. We have this thing, right? I have to convert into numerical form. So if I want to convert into numerical form, what I told you, we can use over here bag of word representation. Okay. So for that, from Scikit-learn dot feature extraction dot text. Now you may be worried like, okay, how do I know about this library? See, I'm telling you about this library, right? No need to worry about it. If you kind of, in case if you want to know about it, right? Suppose you forgot, nothing to worry. Just you can go and search over here, bag of word Scikit-learn. Okay, bag of word Scikit-learn, that's it, right? So you'll get the library over. The first option you're getting over here, the library detail. I click here. Now same thing I'm going to do. What I wrote in the code, Scikit-learn dot feature extraction dot text. This is what I write over here. Same thing is present over here. Scikit-learn dot feature extraction dot text. Right? So it is from the official documentation. Like it's not like that you have to memorize it. You should just know the concept. Right? It's not like that when I have to use bag of word, always this thing always keep in my mind, right? It's not possible. So many thousands of functions are there, thousands of libraries are there, thousands of classes are there. It's not possible that you can keep everything in your mind. What you can keep in your mind? You can keep in your mind about the bag of word concept. Okay? If you know the concept, you can just go to the Google or you can go to any space, right? You can search over there, you will get the documentation, official documentation. Okay, and you can just open up the official documentation and from here you can easily use it. So this guy is saying that Scikit-learn is having a class. The class name is what? Count vectorizer. So I have to just import this guy. So from Scikit-learn dot feature extraction dot text, import count vectorizer. Okay. Now once we kind of import a class. So for a class, object is important. So I'll define an object for this class. Vectorizer is equals to count vectorizer. All right. So once I define the object of this class, now there are few parameters it is showing that you can feed all these parameters. Okay. No need to kind of go into the things like, okay, what are these parameters and all. Just you should take care that what output you require. You require the output as binary, right? You just require the output as binary, right? So just write over here, binary is equals to true. Okay, 1 or 0 is what? Binary, right? Thereafter, you have to do what? There are two functions. Only two methods are there. One is called fit method, other is called transform method. Okay, whenever you use such class, we have only two methods. One is called fit method. Okay, fit method is what? Which is used to tell this particular class about your data. Okay, obviously this class is responsible for what? This class is responsible to convert your data into numerical form. Right? So first this class should know about your data. Right? So fit will just let this class know about your data. Once this guy know about your data, thereafter this guy can transform. Okay, transform. Okay, what the same data. Right. So when I just executed it, you can see what I'm getting with 8 stored elements shape 2 cross 6. Okay, it has just generated some output with a shape of 2 cross 6. Okay, so that is a kind of a, you can say, see why it has generated a 2 cross 6. Let's say over here it is having 1, 2, 3, 4, 5, 6. Okay, 6, and then it is having this guy, that is your chase is also there. Chase is a unique word, so it should 6, 7, 8. So it should be 2 cross 7. Anyway, let's check the output. So here this had generated the output. That output over here is bag. I can just store that as a bag matrix. So I'll check the output. Okay, now that output I'll convert into array. Bag matrix 2 underscore array. To show that output, I have to convert into array. To array, I guess this underscore is not there. Maybe. Okay, fine. So now it is giving me this output, right? So let's try to understand what it did. Here I have 2 cross 6, right? So first I have a word. It will be like this. I am a good. Okay, I am a good cricket player. All right. Now it is having I am a bad chess player. So this guy is not picking up the bad word or what. Anyway, to confirm this thing, what I will do, here bag of word we have in which we just fit the data, right? Now this, as per my expectation, it should be 2 cross 7. Okay, because I am a good cricket player. Up to here it is fine. In the second sentence, I and M is there. But bad and chess, there are two different words. Those words are not present over here. So it should be 2 cross 8. Okay, 2 more words should be there for bad and chess, but it is not showing like that. So I have to confirm what it is doing. So to confirm that, this vectorizer I already have. Vectorizer I will call dot. There is a method that I can call over here called get feature names. Okay, get feature names out. Right. So if I am checking this feature name, it is just picking up what am bad chess cricket good player. Right. That means there are few words it is not picking up. What? It is not considering over here these words I and A. That means these words are like kind of, there are some words which are considered as stop words. The stop words means what? The words which are important to frame a sentence, but not so much important to decide anything or to predict anything. Okay, like if I have to predict sentiment. So for predicting the sentiment, I is not an important word. Okay, to predict a sentiment, I is not an important word. That's why there are few words, okay, which this guy ignores. Okay, why it ignores? So that your data size can be smaller. Okay, after transformation, your data size can be smaller. That's why it is ignoring it. If I will change it, let's say instead of I, if I will use something else, then it may not ignore it. Okay, let's say I use over here like Raju. Okay, and here I use, let's say, Sanjay. Okay, and then again I'll try to do the same thing. Okay, so now it is not ignoring it. Okay, it is picking up these words, right? So there are there are some predefined words are there, I, A, kind of things, which generally it ignores. Now, what are the words ignore? That you need not to go into that part, like what are the words it will ignore. Whatever the word, there are 10, 12 words are there. By default, it is already defined within this library to ignore, so it is just ignoring them, right? As those words, you don't find it very important for deciding something or for the training purpose. Okay, there are few predefined words are there which are not so important for the training purpose. That's why it ignores them, right? So now if I say that instead of I had added Raju and Sanjay, so these two guys added over here. As these two guys are added over here, this size also increases. Right, now I'll do what? So I'll just convert this thing into a data frame using pandas. Now what is pandas? Pandas are basically the Excel for Python. Okay, you must have used Excel. What Excel do? Excel store the structured data. So in Python, if you have to store the structured data, right? Structured means what? Tabular data, right? So pandas is used. Pandas, with the help of pandas, you can create a proper table. You can see a table. Right. Now this table is having how many columns? This table is having 8 columns. Why? Because from your given document, this particular library finds out 8 unique words. It finds out what? 8 unique words. Right? So the first is representing am, second is representing bad, third is representing chase, then it is cricket, then it is good, then it is player, then it is Raju, then it is Sanjay. Alright, so now let me just try to give them the column names. Column names will be equals to what? This guy. Okay. So now it's done. Okay. So if I will just compare over here, just pick the one. In the first line, what are the one? Rajiv, M, but why it is M over here? Rajiv, M, Rajiv is, it should be easier, right? Okay. Alright. So age it is considering. So let's say in the first line we have Raju is, why is not, why it is M is still coming? Sanjay is okay. Here M is. Okay, that's better. So now we have what? In the first sentence we have Raju is okay, good cricket player. Right. So if you just check 1, 1, 1, 1, 1. So because of these ones, if you check, your sentence will be completed. Okay. In the second sentence, Sanjay is bad chess player. Right. So you may be thinking like, you know, it's not putting the things in a sequence. It is not putting like, you know, Sanjay came at the end, right? And then the next word after the Sanjay is over here. Sanjay is, okay, then bad, then chess, then player, right? So it's not sequential. Obviously, it is not sequential. And as I told you earlier, I will tell you the benefits and the problem with the bag of words. This is your problem with the bag of words. After transforming into numerical form, it will not keep the meaning of the sentence as it is. Because the sentence, you can say the complete sentence are not remain in the same sequence. Okay, the encoding is not done in the same sequence. That means your each word is considered individually. Okay, what bag of word is considering? It is just considering each word individually. Okay, bag of word is not considering that what a particular sentence means. Okay, Sanjay is bad chess player. So this particular sentence is having certain meaning, right? It is giving you certain context, but when you convert it into this numerical form, that context gets lost. Okay, it will not keep the meaning intact. It will not kind of keep the sequential meaning as it is. It will just use all the words separately. Right. Now, once we have this data, what you can do, if you are working on the sentiment analysis, you know the first sentence is a good sentiment, so you can label it 1, you can label it 0. Why? It means positive sentiment, it means negative sentiment. And now you can use this total data to train a machine. Okay, machine will try to learn from this data that how you know, good sentiment word looks like and how a bad sentiment sentence looks like. All right. Okay, but the problem with this kind of encoding is what? There are so many other problems are there. If you will just kind of try to understand like what are the problems with these kind of encoding. The most important problem, the most basic problem that we have is what? It's like, obviously it is just considering each word separately, right? It is not keeping the meaning of the word, it is not keeping the context of the sentence intact. Each word is considered separately. If you have very large document, suppose you have 1000 words, Okay, so for 1000 words, there will be a 1000 data column will be created. Okay, if you are working on 1000 words, there will be a 1000 data columns will get created, right? Like suppose you are working on a very large document. Let's say you are working on this kind of document. In this document, you have a lot of words. Now you want to use this document to convert into numerical form, right? So if you convert this into numerical form, it will have lot of, like thousands or hundreds of thousands of unique words. So as many unique words, that many data columns. All right. So that's how it works. All right. So that's the basic problem we have. And what other limitation that you can see? Okay. So let me just write those points about the things. Okay. It is what are the limitations? Okay, why it is important to understand, then only we can think of some other solution. Okay, no semantic understanding. Semantic means what? Meaningful understanding. It is not trying to understand what a sentence actually means. Okay, so if it will not have a semantic understanding, then what happens? Then it will consider if you are using apple in two ways. Suppose you are using apple, like in one sentence you have used apple as a fruit, and in the other sentence you have used apple as a company. Okay, here you use apple as a fruit, right? So this kind of transformation will consider both the apples same, right? This kind of transformation will do what? Will consider both the apples same. That's the problem, because it is not having any semantic understanding. It is not trying to get the meaning out of the context. It is not trying to learn from the context. It is not trying to understand the context. Okay, just converting the words into numerical form. Okay, that is one problem, right? Next problem, it's like obviously it ignores grammar and everything. Okay, it ignores word orders and grammars, right? Like Sanjay was at the top, after encoding it goes to the end, so completely order is changed, right? Now if you are working with suppose you are working with some of the data in which after you train the model, right? Suppose you train the model. After training a model, you are giving some input. Okay, like suppose here this guy get a label 1, this guy get a label 0, and using this whole information you train the model. Okay, a trained model to identify sentiment. Okay, now to this trained model you are feeding a new sentence. Okay, and asking it to tell the sentiment. Okay, and that sentence is having some new word, a word which is not present over here. Okay, that sentence is having a new word which is not present over here. So this particular encoding is not good in handling the out of vocabulary word. Okay, so if a new word will be given which is not present in the training data, which is called out of vocabulary. Okay, so out of vocabulary words, out of vocabulary if the spelling is wrong, please correct yourself. So out of vocabulary words will be are simply ignored when we use a trained model. Okay, that is again a problem, right? And yeah, so these are the certain problem we have. So to address these kind of limitation, we need some more advanced technique, or we need some other technique that can be used for this thing, that is your encoding. So there's some other technique that came into picture is TF-IDF, term frequency inverse document frequency. I'll tell you. Then after there is a encoding technique that came into picture, that is called Ngram. Okay, thereafter so many word embedding techniques are there. Word embedding techniques are there. Word embedding means what? Converting word into numerical form. What are those? Word to vec. Okay, word to vec. Thereafter glow, that I'll try to explain. Right. Thereafter some deep learning models are there like RNN, LSTM and transformer. So many development happened, but the first thing that we created was this one. Okay, the first thing we created was bag of words. After bag of words, the next thing that we used was TF-IDF. Okay, so TF-IDF does what? Term frequency inverse document frequency. That is again something that is used for converting the words into numerical form. Okay, the form is what? Here some calculations happen. TF-IDF. What it means? Term frequency inverse document frequency. So here some math is involved. Okay. Before I tell you about the math, I'll tell you that it do what? If you are feeding some document, that means some sentence. Document means what? Sentence. Okay. For example, I have a sentence over here. AI is our future. That is one sentence. The second sentence, let's say over here, AI will save the future. Okay. And the third sentence I'll use over here, let's say, AI and data science will change the world. Okay, something like this. Right. Now, in this thing, what happened? AI is used in all the three sentences. Right. So, this particular technique do what? When converting it into the numerical form, it will give the least weightage to the AI. Because AI is repeated everywhere. It is not creating any difference. So least weightage will be given to this guy. Okay, like in our previous example, here, like when I used it, let's say in our previous example only here, I am a good cricket player. I am a bad chess player. So what TF-IDF will do? The word which are very common, like this word is common. So this will be given a very lesser weightage. This is also common, a very lesser weightage. This is also common, a very, no, this is not common, sorry. Yeah, this is common, no, this is not common. Here, player is also common. It will be given a very lesser weightage. So these words will be given a very lesser weightage. Lesser weightage means what? A very small numerical value like 0.1 or 0.0, 0.005, right? These words will be given a very small numerical value, right? And the words which are not common, they will be given a higher numerical value, right? Like 0.9, 0.8, okay? These will be given a higher numerical value. That means when converting it into the numerical form, the word which is common throughout the document, they will get a low numerical value, and the word which is not common throughout the document will get a higher numerical value. Right? So that during the training process, algorithm will know that which word to be focused and which word to not to be focused. Because to decide this is positive or this is negative sentiment, what is important? I is not important, M is not important, this particular word is important. Okay, these two words are important, which is deciding that it is a positive sentiment, it is a negative sentiment. Right? So before I can give it for the training, here I had given everything 1-1. Right? Here I had given good as 1, here I had given bad also 1. So in this case, what? We are completely relying upon the training. Okay, here we are completely relying upon what? Machine learning algorithm. Okay, we are waiting that machine learning algorithm should learn something from this data to decide positive or negative. We are not helping the machine learning algorithm. We just converted them 1 and 0 and given to it and asking it to learn from it. But here actually we are helping the machine learning algorithm. Before giving the data to the machine learning algorithm, okay, we are encoding it in a way that automatically the word which is common gets the very low numerical value, and the word which is not common gets the higher numerical value. So machine learning algorithm can now easily identify that, okay, here I am getting the higher numerical value. That means here I have to focus more. This is creating the difference. Okay, this is creating the difference. Because learning will be based on what? Differences, right? Whatever we learn, like in our day-to-day life also, it's the different thing that we see from that we learn. Same thing if I suppose like morning to evening, if the same thing I'll take my example. Suppose if I have been given a job that you have to only teach data science. Okay, from morning to evening you have to just teach data science. So what I will learn? I will just learn the data science and not learn any new thing. Right? How do I learn new thing? I learn when the differences will come. When someone say, no, you have to teach machine learning, you have to teach this thing, generative AI. So those differences actually helps me learn. Same way, machine also learns from the differences in the data. If the same kind of data you give, every time you are giving the same data, then what a machine will learn, right? What algorithm can learn from that, right? So same thing over here. What it does in TF-IDF, those words which are common, they get a very low value, and those words which are not common, they will get a higher value, right? So let's say I'll also do it through the through that thing which is called Python. But before doing it through Python, I'll tell you over here through mathematical processes, right? So there is a formula for TF-IDF. Okay, TF, that is called term frequency. Okay, it actually measures how. Now again, one more thing, the concept that I'm telling you, bag of words, TF-IDF, embedding, right? If you forgot these concepts, deeper understanding, if you're forgetting, that is acceptable, but please don't forget these terms. Okay, because when you go for the interview, sometimes the questions are asked like, if I have a text data, then how that text data a machine will learn, or how a text data converted into the numerical form, right? So generally people say that a text data can be converted into numerical form using word embedding. Now that word embedding everyone knows. Okay, word embedding everyone knows. With the word embedding, it will be definitely converted. But if you can, give some good sort of, if you want to be different, okay, you can answer it like that. Again, there are so many techniques are there to convert, convert the words into the numerical form. Initially, we were using bag of words. Then we used TF-IDF. From the TF-IDF, we went to the integer encoding. Then we work on the vectorization. And as this process evolved, nowadays we are using embeddings. Right? So if you use these terms right in your answer, it gives a sense to the interviewer, or it gives a sense to the person who is asking the question that actually you have a very depth knowledge. Okay, even if you are knowing, you are not knowing, that is different thing, right? But if you use these kind of words, it gives a sense that yeah, you have actually some in-depth knowledge, right? So that's why I'm telling you these things. Otherwise, I could have directly started with the embeddings, right? And actually, when you understood these things, embedding you can understand very easily, right? If I directly start with the embedding, it will be very difficult for me to explain embedding to you. But I know if I cover these concepts and then I come to embedding, it will be very easier for me to explain embedding to you. Right? Okay. So what TF measures? TF measures how frequently a word appears in a document. Okay. This just measures how frequently a word appears in the document. The formula for the TF over here is TF formula is number of times. Just a minute. Number of times T appears. Okay, T appears in document D. T means what? T means the word. Okay, number of times T appears in document D divided by total number of terms in document D. Okay, that is called TF. Okay, it can be calculated like this. T comma. Now, if it is not clear about T and D, don't worry. I'll explain to you. Okay, I'll explain to you what is T and what is D. Right? Like for example, let's say let's say I have a sentence over here. Okay, 3 sentences are AI. Okay, now I have to calculate the TF for AI. Okay, let's say I have to calculate the TF for AI, or I have to calculate the TF for future. Okay, so how can I calculate? Let's say I have to calculate the TF, or you can say term frequency. Term frequency for future. Okay, future is a word over here. If you see, future is there. Okay, now if you see over here, future for the document 1. Let's consider we are just term frequency for future for document 1. Okay, for each document it will be different. So term frequency for future for document 1. How many times future appear in a document 1? Future is there for just one time. Okay, so future is there for just one time. Okay, so let me write it over here. Number of times future appear in D1. It is equals to what? One time. Okay, and how many words are there? Total number of words. Total number of words in document 1. How many words are there? 4 words. So it will be 4. So TF is equals to what? 1 upon 4. That's it. Okay. Now same thing. Let's say I have to calculate over here term that is equals to 0.25. Term frequency for future in document 2. Okay. Document 2, how many times future is there? Number of times future in document 2. That will be equals to what? 1. Just one time it is there. In document 2 also it is one time. But total number of what is what? 1, 2, 3, 4, 5. It is 5 times. Right. So total number of words. Okay. Total number of words is equals to what? 5. So TF will be equals to what? 1 upon 5. That is equal to 0.2. Isn't it? So term frequency for the first guy, for the first document, future is what? 0. So each word is having their own term frequency. Okay. Like term frequency for AI is what? 0.25. Term frequency for each is what? 0.25. 1 upon 4, 1 upon 4, 1 upon 4, 1 upon 4, 1 upon 5, 1 upon 5, 1 upon 5, 1 upon 5. Right? So it is like this. Right? So now this is called TF. Now what is IDF? IDF stands for what? Inverse document frequency. Okay. Next thing we use over here, IDF. Okay. It stands for what? Inverse document frequency. It measures how important, okay, a term is across all documents. Okay, so what I told you, TF-IDF is used to convert the words into numerical form. Bag of words also used to convert the words into numerical form. But bag of word is giving the value only 0 or 1. TF-IDF will give the value between 0 to 1. It can be 0.3, 0.4, 0.5, 0.6, 0.1, anything, any 0 point between 0 to 1. Now, here if I will, if I have what I told you, this will give a higher weightage to those words which are not common, and it will give a lower weightage to those words which are common, which are very common in different sentences. If the words which are very common in different sentences, they will get the lower weightage, and that will be controlled by IDF. Just read over here. Measures how important a term is across all documents. That means if a term which is used for so many times will get a lesser importance, and if a term which is used for lesser number of times will get a higher importance. All right. The formula for IDF is equals to N. Okay. N is total number of document. Okay. N is what? Total number of document. I'll write it upon. That means if I have 3 documents, the value of N is 3. 1 plus number of documents containing term T. Okay. This will be within bracket and there will be a log of it. Okay. So IDF for T. Right. It means if there is a term like AI is used for all 3 documents. As AI is used for all 3 documents, the denominator will increase. Then automatically IDF will decrease. Alright. So here N is what? Total number of document. Total number of documents. Okay. And we are adding 1 over here. Why are we adding 1? So that there should not be a condition where denominator should be 0. Like suppose some this value sometimes becomes 0. So if anything divided by 0 will become infinite. So you have to avoid such situation. That is called IDF value. Okay. Like for example, let's say if I have to calculate the IDF. Okay. IDF for future. Okay. IDF for future. So IDF for future will be what? 3. Total number of document is what? 3. 3 sentences are there, right? And then here 3 upon 1 plus what 2? Why 2? Because out of 3 documents, in 2 documents future is used. Okay. Out of 3 documents, we have 2 documents in which future is present. Alright. So this will be equals to what? This becomes log of 1, right? And log of 1 is equals to actually 0, right? So based on this, if I will calculate the TF-IDF, okay, that would be equals to TF multiplied by IDF, okay, that would be equals to 0.25 multiplied by 0, here it will become 0, right? So as future is not a unique character, so TF-IDF we are getting over here very low, right? We are getting a very low TF-IDF, but generally what happened, we do one more thing in TF in this formula, okay? Because here I'm getting 0, just to avoid such situation. Okay, we just need to avoid such situation. It should not be 0 over here, right? Because there are so many words, and for some words I'm getting 0%. So many words I'm getting 0. So again, it may possible a lot of words will get a value 0, right? So to avoid this thing, the formula have been little bit improvised. Okay, 1 plus n we do over here, and then plus 1. If I do it like this, then I'll not get 0. Alright, we'll get some value at least. Like for example, if I use it over, let's say 1 plus this one, okay, and then over here I'll use plus 1. Okay, the formula that I told you was also the correct formula, but that formula is very raw formula. But with time, people has improvised it. Okay, so that any word should not get a value 0, right? So obviously it is still controlled by frequency. Like, you know, if there is any word which is very, which is being used for so many number of times, if there is any word which is being used for so many number of times, isn't it? Okay, if there is any word which is used for so many number of times, then this denominator will be higher. Okay, like suppose there is a word, okay, which is used for just one time. Okay, so in that case, this will be 1. Okay, but if there is a word which is used for 2 times, so this will be 2. So if I use 1, the value will be higher. If I use 2, automatically value will go low. So ultimately what I want that IDF value should be low for those words which is common. Right. Now if I calculate it, log 4/3 plus 1. Okay. So log 4/3 is what? Can anyone let me know what is log 4/? Let me calculate actually. I'm not sure about it. I'll try to calculate using calculator. Log 4 divided by 3, right? So this is equal to 0.124, okay, or 0.125 plus 1. All right. So that will be almost equals to 1.125. Okay. Now what we do? We will just multiply over here 1.125. That would be equals to what? Just a minute. 1.125 multiplied by 0.25. That is equals to 0.28. Okay, 0.28. Okay, this is the representation of future. So future will be represented by what? 0.28. Okay, this value will be higher if future is used for very less number of times. This value is lower because future is used for more number of times. If you try to calculate it for AI, let's try to calculate a TF-IDF for AI. Okay, so TF for AI is equals to what? Again, for the document 1, it is let's say for the document 1 we are calculating. Okay, let's say here I am calculating AI. Okay, AI. Sorry, I try to calculate over here TF of AI for document 1. That would be equals to what? AI is there for one time, total 4 words, so 0.25. IDF will be equals to what? IDF will equals to number of document upon 1 plus, okay, this is your formula of IDF, 1 plus n upon number of document containing term T. Okay, so number of document containing term T, and this is what? Log plus 1. So log of 1 plus, how many documents are there? Obviously we have 3 documents. And then how many documents are containing the term this one? That is 1 plus, how many documents are containing AI? It is 3 documents are containing AI, right? There are 3 documents which are, all 3 documents are containing AI over here, isn't it? All 3 documents are containing what? AI, AI, AI. All 3 documents are containing AI over here, right? Okay. So now if I will use it plus 1, right? So this will be equals to what? Log 1 plus 1. That would be equals to what? Log 1 is 0, so it will be equals to 1. Okay. Now if I'll calculate over here TF-IDF, that will be equal to 0.25 multiplied by 1, that is equal to 0.25. Right. So earlier it was 0.28. Okay. When future was there for 2 times. Okay. Future was there in 2 documents. Future was there in document 1 and future was also there in document 2. Okay. In 2 documents future was there, but in 3rd document future was not there. If you see over here, in the 3rd document future is not there. So future got a value 0.28. But AI, which is there for all 3 documents, get a lower value. It get a value what? 0.25. Okay. So if any word which is not there which is less common, like if you calculate it for data science, okay, or if you calculate it for world, they will get a higher value. Okay, if you calculate it for data, so for data what happens? For data, your TA value will be equals to what? TA value 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1 upon 8. 1 upon 8 is what? 0. 1 upon 8 is what? 1 divided by 8. That is 0.125. Okay. TF will be 0.125. What is IDF? IDF will be equals to what? Log of 1 plus n. How many document? 3 document. 1 plus how many document is containing data? Only one document. So 1 plus 1 plus 1. That will be equals to what? Log of 2, right? 3 plus 1, 4. 1 plus log of 2 plus 1. So what is log of 2? What is log of 2? Log of 2 is 0.301, right? Log of 2 is 0.301, so this will become 1.301, right? So 1.301 multiplied by 0. So 1.301 multiplied by 0.125, that is 0.162. Okay, 0.162, right? So if you calculate it, so this is how we actually calculate the values of each of these things, and based on this, the word will get the numerical value. All right. Now, if I want to implement it through Python, okay, so let's try to implement it through Python. Numerically, we had seen, and I also share the complete formula for you. Don't worry about it. But now, if I have to do it through Python, right? So let's try to implement it. TF-IDF encoding using Python. Okay. This is used for what? For document encoding. That means to convert the document into numerical form. That is the purpose. Now, how can you do it through this guy? Through Python, I have to use it. The library is like the library is TF-IDF vectorizer, I guess. Okay, let me just try. I'm not sure about it. So let's say I have a document first. Okay, same documents that I use, just other document I use. Okay, so let's say I'll create a document over here. AI is the future. Okay, thereafter I'll say AI and ML are the future. Okay, let me check if anyone trying to join. Okay, anyone trying to join. Right. So some document I'm creating, AI and ML are the future. Thereafter, physics is interesting. Okay. Is an interesting. Or is an interesting subject. Okay. Next, let's say I am interested in the concepts of physics. Alright. Now I do what? I have to convert into numerical form, right? So for that, see, if I don't know about it, right, that which library to use, right? Suppose I forgot it, no problem. I'll go to Google and here I'll search what? TF-IDF Scikit-learn. Okay, so it's fine. Now I'll get the documentation. I'll go over here and I'll take this. Okay, this thing I'll copy. Okay, I come over here, paste it over, right? Now I just put from Scikit-learn.feature extraction.text import TF-IDF vectorizer. That's it, right? And then when we import a library or we import a class, what do we do next? We define an object for this class, like we defined earlier. So same thing we have to do, vectorizer vectorizer is equals to what happened? Anyone is my screen is stuck. My screen, I guess it's fine. Is it my screen is stuck for anyone? See, I'm just changing my screen. Like it's fine, right? Okay. Okay, you can just rejoin once. Okay, just in case if it is stuck, just do what? Just click on this thing. That is, just refresh this. Quickly refresh this. It's fine. I guess sometimes it may happen, but it's okay. Okay, so vectorizer is equals to, I have to just define this guy over here. Alright, like we did earlier. Okay, so once we define the object, what we do with this object, we fit the data, right? Like I told you, so I take this object, dot fit, okay, and I'll give this data to this guy, docs. Okay, so this guy will get the docs. So once it will get the docs, what it will do? It knows about this document, that this document to be converted into numerical form so that a machine can learn from it, because machine can't learn from the words, machine only learns, algorithm only learns from the numerical value. Okay, so if I have a numerical value, I can use that numerical value in the algorithm and the algorithm will learn from that. So now I will check over here. First thing I'll check whether it is identifying all the unique words or not. So for that, vectorizer dot get feature names out. So when I call it, it identified all the unique words which will be converted into numerical form. Right. Now if I want to convert into numerical form, what I do? Fit is done. What I told you, the next function, transform. So here what changes? Only the library changes. Rest everything is same. Okay, rest whatever we are using is not changing. It's not like that you have to kind of give any stress that different library, different functions. No, only this line changes. Okay, apart from that, everything is same. Call the library, define the object, fit the data, transform the data. Alright. So now when I'm transforming, here is a transformed output like we did it. Bag matrix. Here I should give what some name. I should give what name I should give. TF-IDF matrix. Done. Now, if it is a TF-IDF matrix, how can I get the actual matrix? By converting this thing into array, like we did it last time. Okay, we get the values over here, but this value is not so much clear. But I'll tell you what it is showing actually. It is like this. See, it is your first sentence. This is your second sentence, third sentence, and the fourth sentence. Right? We can make it more structured by converting this into data frame. So pd dot data frame. When I convert into data frame, we get a tabular data over here. Right? Now we have 16 columns. Why do we have 16 columns? Because we have 16 values over here. Right? So this thing is your column names. All right. Okay. So here each word get a numerical value, and that value is somewhat trying to these values are given based on the importance of the word. Okay, how a word is important. If a word is more important, which word is more important, which is less used. Okay, whichever word is less used throughout a document, that word it is considering as a more important word. Okay, because that word is creating some sort of difference, and the word which is more used, it is considering it as a lesser importance word. Right. So based on that, it has given it a numerical transformation. Now, can anyone tell me if there is any limitations of TF-IDF? What is the limitation of TF-IDF? The limitation is, few limitations are seen. It is also not having the semantic understanding. Here also you can see the complete, sequence is changed. Okay, it is not in the same sequence as we have the sentence. So it is not having the semantic understanding. It is not trying to understand the context. It is not trying to understand the context or meaning of complete sentence, right? So that is a problem. Okay, like for example, if I'm using a word car and in the same sentence I'm using automobile, so it will not understand that car belongs to automobile, right? It will not have that kind of understanding. It is also ignoring the word order and grammar. Okay, like last time, it is also ignoring what the word order and grammar, right? That is also it is doing, right? It is again, it is not having the contextual awareness that I told you. Like it will also consider Apple company and Apple fruit same, right? It will also lead, kind of lead you to create a very large vocabulary, very high dimensional data. Okay, at the end you will have a very high dimensional data set, because suppose 1000 words are there, it will create a 1000 data columns, right? Only one thing it is doing is what? It is just kind of making a data table in which the word importance is basically defined. These values are actually defining the importance of a particular word in each sentence. Rest everything, it is same. Like last time, here 01 is not defining the importance of any word, but here it is defining the importance of a particular word. This thing has been improved over here. That means if I will use this data to train a machine, the algorithm will know which word is important for recognizing something. Okay, this particular transformation or this numerical transformation, if I'm using this transformation, that is converting the words into numerical form, this data can be used for what? For classification purpose. Okay, classification means what? Identifying a sentence as a positive sentiment or negative sentiment. This data can't be used for the generation purpose, right? Like if I want to work on the word generation, okay, I want like this kind of thing. Okay, last time we did it. Okay, if I want to create some model which can do the word generation, okay, like this. Oh, it is not opening up. Why? Oh my god, I did not check it. Just a minute. It is. I thought I had shared this file. No, you also not told me that it is not opening up. Just a minute. Wait a minute. I will upload the Python file actually. Python. Actually, there may be some limitation. Okay. Actually, I have uploaded IPYNB. IPYNB is generally open, sir, but there may be some library I have used. Because of that library, it is not opening. But no worry, I said Python. Okay, so when we use this thing, this was generating the word, right? So when we convert the words into numerical form like this, and I want to create a model which can generate a word, this data can't be used. This data can only be used to create a model which can do the sentiment analysis, right? Like user is giving a review about a product. Now I want a model which can identify the review, whether it is a positive review, whether it's a negative review. So this particular data can be used. Right. Now, what kind of data will be used for this thing? That is your, word generation or something like that. So for that, we'll try to learn what word embedding. The next class that we will work is what is related to word embedding. Right. In that, we will first understand what is integer embedding, and thereafter what is word vectors. Right. We will focus on, we'll try to understand few things, that is what is integer embedding, and thereafter what are word vectors. So if you get some time, please do a little search. Okay, you can just search like this. You can go over here, let's say word embedding. Okay, you get some information. Okay, just give 5, 7, 10 minutes of time to understand what is word embedding, right? Or you can also search over here word vectors. Okay. So you'll get some information. This capture meaning of relationship. They allow machine to grasp the semantic relationship. The semantic relationship that is not getting captured over here through TF-IDF and through bag of words. It is not getting captured, but it can be captured if I work on word embedding. Right? But these knowledge is very important, right? Because if you don't have this understanding, the understanding of next thing will be a little difficult. So that's why I covered it for you. What file name shall I give it? So, what we had discussed in the last class, it was kind of encoding processes that I tried to explain you, like how actually words are converted into numerical form. Okay, like bag of words, and this one I had used, that is TF-IDF. Okay, so both the things are considering each word individually, but after encoding, these numbers are actually not containing the sequence. Okay, it is not preserving the sequence, okay, of the words that are used to form the sentence. Right, just a minute. All right. So it's like, they are converted into 0, 1, 1, 0 kind of thing, or they have been converted into a particular float value. Okay, but here it is, these values are not even storing the importance of the word and not even keeping the sequence intact. Here it is at least trying to, kind of these value, at least trying to preserve the importance of the word. If a word which is appeared for so many number of times, like first time it is 0.52, then 0.36, and then the value goes to 0, right? So if some word which is appeared for so many times, they will get a lesser weightage, and if a word which is appeared for lesser number of times will get a higher weightage. But still it is not holding the sequential information. Next, we will go ahead for the next type of encoding, which is called integer encoding. Okay, integer encoding will be somewhat trying to preserve the information in your text. Okay, like for example, let's say I have a data. Okay, let's say some text I have. First of all, I'll explain and then we'll try to implement it, right? And this is the first encoding from here, which is important for the next encoding that are used in actual RNN or higher end, architecture like transformer, right? So that's why understanding of integer encoding is very important. Let's say I have a text over here. It can be any text. Let's say generative AI is interesting. Okay, let's say this is one text. Okay, now second text, let's say AI is transforming the world, like this, right? Now if I have to encode it, what I do, like the last time what we did when we were doing the bag of words, we try to identify all the unique words, right? In bag of words, in TF-IDF, every time the first step is what? Tokenization. So tokenization actually helps us to identify all the unique words. Okay, so here I have all the unique words that I'm identifying. Interesting. Okay, then AI is already used, so transforming the world. Now okay, now if I talk about this thing, that is your bag of words, or if I talk about TF-IDF, so they will get some value, either 0 or 1 kind of thing based on the text data. Here they will get a value like this: 1, 2, 3, 4, 5, 6, 7. They get some integer value, right? Based on the integer value, the first document will be represented by 1, 2, 3, and 4. Okay, this is how your first document will be represented. Document 2 will be represented by 2, 3, 5, 6, 7. Okay. So in this way, we will represent our document in the numerical form. Okay. Here 0 is added just to make it structured. Okay. So that your data can be structured. Because text data is what? It is structured. So we added 0 so that all the samples can have the equal number of rows and columns. So now if I am storing the value like this 1, 2, 3, 4, 0. Okay, so somewhat this particular values is in the same sequence as your words are present, right? At least these guys are what are kind of holding the sequence, right? Whatever the sequence of words to form the sentence. This is called what? Integer encoding, right? So integer encoding first we do, and thereafter we'll go for the next step of the encoding, which is called embedding. From the integer encoding, we'll move to the next thing, which is called embedding. So first of all, let's try to do this thing that is called integer encoding, right? So we'll go to the Python part. Now we are moving to the steps. Okay, we are moving towards that particular stage where we will see how actually the words are used by the machine to learn something. Okay, how actually a word can be used by a machine to learn something, right? So this is the thing that we need to understand. Let's say I have a text. Okay, like the same text I'll use generative AI is interesting. This is the first sentence. Second sentence is what? AI is transforming the world. Okay. Third sentence is like I want to know about AI more. Okay. Now at this stage we know if I want to use TF-IDF or if I want to use bag of words, how this thing can be converted into numerical form. But now we are going to use what? Integer encoding, right? So for the integer encoding, we have to, let me just write it over here. Okay. Now, in last class, what I told you, if I have to do the encoding, obviously we will not do it manually. We require library, right? So if I have to do the integer encoding and I don't know about the library, what I can do? I can just go over here, okay, and can search for integer encoding Python. Okay, like this, right? So now we get some of the options over here. Okay, how can you do the integer encoding? There are so many ways, like Scikit-learn preprocessing level encoder you can use, right? Or the codex library is there that you can use, right? So many ways are there through which you can do this thing, right? So if we do any kind of encoding, what is the first process that we do? Here, we just import a library, then we fit the data over here and it is done, right? This is what we do, isn't it? Here also we do the same thing. There are multiple ways are there. You can just try to use any one of these ways. Okay, just here you can see the library is already given. Okay, here also library is already given. You can just open this thing, and if you scroll down, you get the sample code. Okay, some sample code you will get. Where is it? It's not there. Just a minute. Why it is not showing? Let me check others. Original encoder. Here. Okay, here you'll get some of the sample code, right? So you can use these sample codes, but if you are going to do the integer encoding, the better library that you can use is TensorFlow. Okay, like for TF-IDF, for bag of words, we had used Scikit-learn. For an integer encoding, TensorFlow is good. Okay, it is easy to use and it handles the very large scale of data quite easily, right? So here library is mentioned over here with TensorFlow. Okay, so here TensorFlow dot, I should use tokenizer. Why it is not showing? I guess here it will show. Pre-processing the tokenizer. It's not showing. Yeah, it's showing here over here. Okay, here it is showing TensorFlow. Okay, so here using this TensorFlow, actually we do this kind of encoding. Okay, because when we work with a very large scale data, we move to the TensorFlow. TensorFlow is a framework given by Google, okay, which is being created for very large scale data. A small to medium scale data, Scikit-learn, okay, but for large scale data, TensorFlow, right? Scikit-learn that we use in the last class, but now onwards we are going to use TensorFlow because we are going to handle very large scale data, right? So if I have to encode it, so first I'll encode from TensorFlow dot preprocessing dot text. TensorFlow dot pre dot Keras, I guess. TensorFlow dot Keras dot preprocessing dot text. Yeah. Keras is a library which is built on top of TensorFlow. Okay. There are two things we are using. TensorFlow is a framework. Okay. TensorFlow is a framework given by Google, which is used to perform any sort of mathematical calculations. Okay. If you have very large scale numerical values and you have to do the mathematical calculations, then we require TensorFlow. Now you may be thinking why we require TensorFlow. We require it because I'll tell you. See, if you have a information like this, a is equals to 5, b is equals to 2, and you have to do a multiplied by b, it can be done without any library. Okay, but if you have information like this, okay, this is a matrix, okay, and you have to do what? A multiplied by b. Okay, so to operate on it, we use NumPy or some other library like SciPy, right? These things we can use. But when this matrix becomes tensors means what? N-dimensional matrix. Okay, tensors means actually n-dimensional matrix. Okay, it's a huge matrix data. I'll show you tensors. Okay, if I just search for tensors and I search for images, okay, these are called tensors. Okay, here these are called 6-dimensional tensors. This is 1-dimensional tensor, 2-dimensional, 3-dimensional. So tensors are actually multi-dimensional. Okay, up to here it's fine. See, up to this guy, your normal libraries or normal framework is good to go. But when this kind of data we start working with, okay, 1, 3-dimensional, 4-dimensional, 5-dimensionals, okay, in such cases, the normal NumPy or kind of SciPy is not enough to handle or process or calculate the things. Okay, what? Because to get a result, you require processing. Processing requires a lot of calculations. So those calculations is not done accurately with the libraries like NumPy or with the libraries like SciPy, with the basic libraries basically, right? That's why Google had created this particular framework, TensorFlow, which is being created in a way that it can handle the huge n-dimensional tensors efficiently and can perform the calculations at a very high accuracy. Right, and this Keras is a library which is built on the top of TensorFlow. That means Keras is just some of the programs which are written, which basically do what? Which uses TensorFlow in its backend, okay, and performs the like for different kinds of functions, okay. Like you can consider it like this. Keras will create these kind of environment and TensorFlow will perform calculations on these environment. Okay, Keras will create these kind of architecture with the help of program. Obviously, these architecture you are not going to create with wood. You require program. So with the help of program, Keras will create these kind of architecture, and TensorFlow will perform the calculations required to get a result. All right, that's why we are importing over here from Keras, TensorFlow.keras.preprocessing.text import tokenizer. So what tokenizer will do? Tokenizer will just create the tokens. Okay, so let's how to create a token. Last class I told you this is a final class, so I need over here it's a capital T most probably. Okay, I need an object tokenizer is equals to this tokenizer. So the object is defined. This object requires a method. So the method that is used over here is fit method, just like last time we had used tokenizer.fit. Okay, so with the fit, what we fit over here, we will fit the data that is called text. Right, now next, to transform we have to use what? I guess here it is fit on text. The function is slightly different over here. Fit on texts. Okay, so now this is fit. Okay, now because of this TensorFlow, we don't have to create any loop, because we are working on three different data, three different sentences. Okay, we are not creating any loop over here, a loop that will process first sentence, then second sentence, and third sentence. No, okay, we are not creating any loop over here, but still it will get processed because those loops and everything will be handled by TensorFlow and Keras. Now, what are the tokens? Let's see. Print tokenizer dot word index. What is word index? See, this is what I told you. Each word will get a numerical value like this. Okay, same thing happened over here. All the unique words got a numerical value from 1 to 13 because there are 13 unique words. Right? Now, we have to convert this text into the sequence. Right? So again, tokenizer representing a tokenizer class dot text to sequences. That means I have to convert the text into the numerical sequence. Okay, so this tokenizer actually knows about the numbers, it knows about the numbers for each word. Okay, this tokenizer object knows that AI is represented by 1, okay, is represented by 2, generative is 3, interesting is 4, transforming is 5, the is 6. It knows about it. So when I feed this sentence that is called text over here, this guy will convert this sequence into the numerical, this text into the numerical sequence. So you have a numerical sequence like this. Right? Okay. So here, if you say 3124, what is 3124? What is 3 over here? 3 is generative. Okay. 1 is what? AI. 2 is what? Is. 4 is what? Interesting. So generative AI is interesting. We get it over here. Right. So same way we can do what? Here we have a sequence of each of them. But here there is a problem. The problem is this data is unstructured. Why it is unstructured? It is unstructured because this. The first sample is having 4 values, second sample is having 5 values, and third sample is having 7 values. Right? That's why to convert it into a structured form, we have to perform over here padding. So from keras.utils import pad sequences. Okay. Now here this library will do what? Will perform the padding. What padding does? Padding will add this 0 that I told you. This 0 will be added by padding. So Keras library will do it. So I can just call over here pad sequences. Okay, and this information will feed it to this guy. That means I can store this thing into sequences. This is sequences. Okay, and then this sequences will capture from here and paste it over here. Right. So if you see here, padding is done. This is called what? Pre-padding. By default, the padding is pre-padding. Okay. So this is your padding done, and this we call as a padded sequences. Done. Okay. All right. So this is how your first integer encoding is done. Right now, what to do with this integer encoding? This integer encoding will be later on converted into the embeddings. Okay, now we have to perform the word embedding. I'll show you. Before moving ahead, what I do, I'll just give this file to you. Just a minute. Word encoding. G22. This is your third class, right? No, this is your fourth class. I'm sharing this file with you. Please have a look, and then I'll go for the next thing. Like I'll now tell you why this integer encoding is required. Okay, first have a look on it. Okay, thereafter I'll try to explain why this integer encoding is required, right? Done? Okay, so now see what happened. When you have to make a model, okay, model which can learn about a text. Okay, I need a model which can learn about a text. All right. So before we discuss this thing, that how a model will learn about a text, okay, let's try to understand a very simple use case. Okay, where let's say I have a information about the advertisement expenses. Let's say advertisement expenses on TV, okay, and advertisement expenses on social media, right? And then let's say here I have a sales value, right? So now there is a company who had recorded this information. Okay, the information recorded is like this: advertisement expenses made on TV, let's say $3,000. Okay, here it is. Just allow me for a minute. Let's say $5,000. Here it's like $10 million. Some sales they are getting, right? So this is the information company had recorded. So similar to it, there will be a lot of information that would be recorded, isn't it? Wait a minute. Okay, sorry, I just. Sorry, I just got some message actually. Okay, fine. So let's say this is a situation I have, right? Now let's say we have some other situation like 2, 7, 12, okay, 3, 8, 11, 4, 7, 9, okay, like this. Now I need a machine learning model which should learn about, these input information and the output that we are getting. Okay, for these inputs we are getting this output. So I need a machine learning model that should learn about this situation. Okay, so that in future, if I am kind of trying to make a prediction about the sales, suppose my advertisement expense is 2, right, on the TV, and on social media it is 5. I want to predict what will be my sales, right? So for that I need a machine learning model. A machine learning model that should learn about this situation, isn't it? Please try to understand this thing very carefully. If you understand this very carefully, it will be easier for me to explain you this particular thing, that why we did integer encoding, right? So please try to understand it. So now over here, what I do, I can just choose a very simple approach. The approach is called linear approach. Linear approach says that there will be a linear equation. Again, in this linear equation, these values, okay, x1, x2 will be represented by the features given to you. Okay, what are the features given? TV expense and social media expense. Okay, these are the features given to you, right? So now I just need to find out these guys. Okay, I need to find out these guys, W0, W1 and W2. Okay, I need to find out these guys for minimum difference or minimum error difference. That is, if this is my error, so for minimum y minus y hat, for minimum y minus y hat, I need to find out these things, which is called trainable parameters, isn't it? That means, let's suppose my W0 value is 1. Okay, let's suppose my W0 value is 1. Okay, and let's suppose I have W1 value is also there. So W1 value is also 1. Let's suppose. Okay, so X1 value is 3. Okay, then W2 value is again 1. Then X2 value is what? 5. Okay, this is something that I have. Alright. Okay, now based on this, what will be y hat? Y hat will be over here 5 plus 3 plus 1, that is 9, isn't it? 5 plus 3 plus 1, that is 9. So this is my y hat. Then what is error? Error is equals to y minus y hat. Again, so y minus y hat is what? 10 minus 9, that is equals to 1. Okay, same way I will also get error for the second guy. Again, for the second, this is error 1. So for the second guy, what happened? It would be 1 multiplied by 2 plus, sorry, it would be 1 multiplied by, 1 plus, we are using linear equation, right? So according to linear equation, see, first look at the linear equation. Here is linear equation, right? So 1 plus 1 into 2 plus 1 into 7. So 7, 8, 9, 1, 10. Okay, so here error will be equals to what? 12 minus 10, that is equals to 2, right? So every time error will be different. Okay, for each sample we will get some of the error value. Okay, because there will always be a difference between y and y hat, right? And this difference can be minimized. How it can be minimized? It can be minimized by tuning these parameters. Okay, it can be minimized what? By tuning these parameters. That's why those parameters are called what? Trainable parameters. What they are called? Trainable parameters. Machine learning model actually try to learn these parameters or learning parameters. Okay, machine learning model will try to learn about these parameters. Once it will learn about these parameters, it finds out the best possible parameter, which is giving the minimum possible error. At that point, learning stops. Right now, how these process happen? There is a process called gradient descent and all. I'll not go in that direction because that is a part of machine learning training. I'm just telling you the overview over here so that I can explain you the process after integer encoding. My whole purpose of explaining this concept is so that I can explain you the concept that will happen after integer encoding. So here what you should know, whenever there is a data is having two parts. One is called features and other is called target. The machine learning model needs to learn about how features and targets are related to each other, so that in future, whenever there is an input given, it can predict the output. Right. So to find out the best relation, we created a linear equation. In this linear equation, these x1, x2 will be replaced by these guys every time. Okay. We have 4 samples, so for the 4 times, these values will be replaced by TV and social media advertisement. And then your algorithm will try to find out the value of these guys, okay, for minimum y minus y hat. For minimum y minus y hat, these things to be figured out. I hope it is clear. Now, this process will go again and again so that you can find out this thing. That means the size of model depends upon what? Depends upon the number of trainable parameters. Number of trainable parameters. Okay, will affect what? The size of model. Okay, if there is a model in which I have 3 trainable parameters and there is a model in which I have 10 trainable parameters, the model which is having 10 trainable parameters will be bigger in size. Okay, the model which is having 3 trainable parameters will be smaller in size, isn't it? Here I have only 3 trainable parameters. Okay, that means whatever my algorithm can do, my algorithm will learn at the end these 3 values: W0, W1 and W2. Whatever my algorithm can do, whatever the tuning I can do, but after tuning tuning everything, after kind of minimizing the error. After minimizing the error, I will have only these 3 things, which I can call as a trained parameter. After minimizing the error, I will have only 3 things which I can call as a trained parameters. Fair enough? So, in case if I have a small data, 3 parameters are good to go. But suppose if I have very huge data, suppose I am working with kind of a 10 million data, 10 million data, right? If I'm working with 10 million data, right, and I have an information like advertisement cost on TV, okay, advertisement cost on like social media and sales, and I have 10 million data. So how only 3 coefficients can satisfy all these 10 million samples? These 3 coefficients may not be enough, okay, to minimize error for all these 10 million samples, right? Because I want minimum error for all 10 million samples. But like see, for example, let me just try to make this thing more simple. See, if I have kind of a equation like this, 2x plus 2y is equals to 7 and x plus 2y is equals to 5. You can find out the x and y value which will fit into this equation. Okay, you can easily find out the values of x and y. Okay, the accurate value of x and y, if you put it, you get 7. If you put it, you get 5. Okay, but suppose if I write so many equations, okay, what I mean, let's say if I write over here 2x plus y is equals to 10, x plus 3y is equal to 7, x plus 9y is equals to 8, 2x plus 5y is equal to 3, right? Thereafter x plus y is equals to 7, x plus 3y is equals to 6. Okay, if I write like this, okay, and we have only 2 unknowns, x and y, but how many equations are there? 1, 2, 3, 4, 5, 6, 6 equations. So how two unknowns X and Y can fit into all these equations? Not possible. Two unknowns can only fit into two equations. Two unknowns can't fit into 6 equations. Okay, it's not possible. It can do what? We can find out the best possible value of X and Y. Okay, we can find out best possible value of X and Y. Okay, which can give you the very close value to these guys. Right, that is what we can. We can't find out exact accurate value. We can find out the best possible value. Same thing over here. I have 10 million samples. That means I have 10 million equations. Right. For 10 million equations, only 3 unknown parameters or only 3 trainable parameters will not be enough to minimize the error. So I need more number of trainable parameters. So how can I have the more number of trainable parameters? I can have the more number of trainable parameters if I know what neural network. So what neural network will do? Here, let's say I have two things over here called TV and social media. So I'll create 2 input neurons. Then I will add hidden neurons over here. Then I will add over here output neuron. Again, now what happened? This will be connected to this hidden neuron. Alright. Then this will be connected to this hidden neuron. Right. Okay. Now this will be connected to this hidden neuron. Sorry. Now this will be connected to this hidden neuron, right? Wait a minute. Okay. Right. Now all of them will be connected to this output neuron. Okay. Now if you see hidden neuron 1, hidden neuron 2, hidden neuron 3, hidden neuron 4. This is called neural network. Right. Now what happened? If I have a TV and sense like this, okay, let's say this is X1, this is X2, right? So hidden neuron 1 will be equals to what? W01 plus W1 X1 plus W2 X2. Okay, because we are considering this thing as a weight 1 and weight 2. Okay, next this is your weight 3 and weight 4. Next, this is your weight 5 and weight 6. Right, this is your weight 7 and weight 8. Right, it means what? It means hidden neuron 2 will be equals to W02 plus W3 X1 plus W4 X2. Hidden neuron 3 will be equals to what? W0 1 W0 2 W03 plus W5 X1 plus W6 X2. Hidden neuron 4 is equals to what? W04 plus W7 X1 plus W8 X2. Okay. Then we have an output neuron. Okay. Output neuron will be equals to what? Again, W05 plus your W9 H1 plus W10 H2 plus W11 H3 plus W12 H4. Right. So now W12 W12 H4. Right. So now how many trainable parameters do you have? You have only 2 input features, TV and radio, so TV and sales, social media. Only 2 input feature, but number of trainable parameters you can count 1, 2, 3, 4, 5, 6, 7, 8. Okay, 9, 10, 11, 12. Right. So now we have 12 trainable parameters plus we have bias value also there. This is called bias value. Okay. So I have plus 5 bias value. So that is equals to 17. Okay. It means what? When I am going through the generic process for a small size data, I was having only 3 trainable parameters. my model size was like this. This is my model size. Okay, only 3 trainable parameters. But when I created a neural network, my model size become like this. Okay. Now I have 17 trainable parameters. That means my model will learn 17 trainable parameters. Okay. So when my data size is very huge and my number of trainable parameters is very less, I create a underfit model. What I create? I create underfit model. But now my data size is quite huge, right? And now I can also anytime increase or decrease the number of trainable parameters. Okay, the number of trainable parameters in my hand, right? Because if suppose I have over here 2 input neurons, considering the TB, right? If I will increase the number of hidden layers or hidden neurons, my trainable parameter will increase. Earlier it was 4, now it is 5, right? As it is 5, so it will become what? 5 into 2 plus 5. That would be equals to 12. This will be connected to this guy. Okay. So 1 into 5 plus 1, that will be equal to 6. So 12 plus 6, 18. Right. So I can easily control it. Sorry, here 15. I'm sorry. So 15 plus 6 will be equals to 21. Right. So in this way, what happens? The output value will be calculated similar way. Okay. The output will be calculated. Then error will be calculated y minus y hat. Then these weights will tune itself, okay, with the help of error optimization algorithm like gradient descent. These weights will tune itself so that your error can be minimized, right? So what changes? Number of trainable parameters changes. If number of trainable parameters change, it means what? It means you are increasing the size of your model. Okay, it means what? Your model will learn more parameters to predict output. Okay, this is the whole summary of it, right? Now the point is, now question is, Vipul, why are you telling all these stuffs? Okay, I'll tell you now why I'm telling you all this stuff. Okay. So see now over here, we get something that is called your numeric representation of your words. Now using these words, I have to train a model. Okay, what I have to do? I have to train a model using these words. All right. Okay. So let's say I have to train a model using these words for any purpose. Okay, let's say for the sentiment analysis, let's say for the next word prediction or generation, anything. Okay, so we'll discuss next word generation later on. Let's talk about the simple process which is called sentiment analysis. Okay, it will be easier to understand, right? So let's say I have 2 sentences over here. Okay, the first sentence is like AI is good and AI is good. Let's say AI is good. Second sentence is what? AI is AI sims. AI is dangerous. AI is dangerous for, or you can say over here, unregulated AI or uncensored AI. Unregulated AI is dangerous for society. Okay, 2 sentences. The first sentence is 1, that is sentiment 1. Second sentence is 0. All right. Now, first I will do what? I have to just identify each unique word. So let's identify each unique word. AI is good, unregulated, dangerous for society. So it will get a value 1, 2, 3, 4, 5, 6, 7. Fair enough. Now I have to represent each sentence with the help of a numeric value. Okay, so for that, first sentence, document 1, 1, 2, 3. Okay, document 2 is 4, 1, unregulated AI is 5, dangerous 6, 7. Okay, so now let me just take this thing over here. Okay, so here. Okay, now this is labeled as 1, this is labeled as 0. Okay, now I have to train a model. All right. So if I want to train a model which can learn about this pattern, okay, what I do? Let's say same process I'll implement. Okay, that means let's say I'll use y hat is equals to w0 plus w1 x1 plus w2 x2 plus w3 x3 plus w4 x4 plus w5 x5 plus w6 x6. All right. So here, w0 plus w1 x1 is 0 plus w2 x2 is 0 plus w3 x3 is 0 plus w4 into 1. Okay, so it would be w4 into 1 plus w5 into 2 plus w6 into 3. All right, this is y hat 1. Y hat 2 will be equals to what? Let's say w0 plus w1 into 4 plus w2 into 1 plus w3 into 2 plus w4 into 5 plus w5 into 6 plus w6 into 7. Okay, for each of them I attached one weight. Here also I attached one weight. Now the error optimization algorithm. Okay, that means first there will be certain values of these weights will be defined. These weights will get certain values. Okay, like 1, 2, 3, whatever. Thereafter there will be an error optimization algorithm. That error optimization algorithm will try to minimize the difference between these two guys. Okay, because y1 is what? Y1 over here is already given, it is 1. Okay, y2 is what? It is 0, representing negative sentiment. This is representing positive sentiment. This is representing negative sentiment. Because I want to build a model which can easily predict positive and negative sentiment. Okay, I want to build a model which can predict positive and negative sentiment. So here we converted all the characters into the numeric value. And when we feed into this algorithm or this equation, the error optimization algorithm will try to first of all, the value of y hat will be calculated. Then error optimization algorithm will tune these values. Which value? W0, W1, W2, so that the difference between y and y hat can be minimized. Okay, and for minimum value of y and y hat, whatever the W0, W1, W2, W3, W4, W5, W6 you have, okay, that will be considered as a trained parameters. Okay, these are what? Trained parameters, right? So now based on these trained parameters, whenever you give any new sentence, okay, if you give any new sentence, that sentence will be first converted into the numeric form, and then those numeric value will be used with these particular coefficients. Okay, first, if you give any sentence like AI is dangerous, so if you give this sentence, it will be converted into numeric form. These numeric value will be multiplied with these things, and then you get the output. The output will be 0 or 1. Okay, that is what fine. But this is good if you have a small size data. What if you have a very large size data? Okay, what you have very large size data, then what can you do? Right? Then there is a challenge over here. Right? So you say if I have large size data, I can use neural network. Yes, obviously you can use neural network, but again there is a problem with that. Okay, as you say, I can use over here neural network. Okay, there are 7 words, so 7 neurons. Okay, then hidden neurons, then over here output neuron. So now my number of weights will increase. Okay, number of weights will increase. That means number of trainable parameters will obviously increase, right? So problem solved. Okay, this is fine. Okay, but the challenge is if you have a very large number of data, or sorry, very large, this thing. Let's say you have this kind of data. Okay, this is even not that large, but still. Okay, so in this data we have thousands of words. If I will have thousands of words, it means what? It means that this particular, we will have thousands of numbers, right? Now let's suppose our largest sentence is containing 100 words. Okay, my largest sentence, okay, is containing 100 words. Or suppose there is a paragraph, someone has given some reviews and all. So largest sentence containing what? Let's say 100 words. Okay, that means one vector will be of 100 digits. Okay, there is a single vector of what? Of 100 digits. You can see over here. The longest sentence over here. Here longest sentence is what? Longest sentence is 1, 2, 3, 4, 5, 6, 7. Okay, that's why the longest vector is of. So as the longest sentence containing 7 words, okay, that's why all of them are now 7, right? So if suppose longest sentence containing 100 words or 1000 words, so it will create a very large, vector over here. So your matrix size will become very big. That is one problem. Second problem, it's like, your each word is over here given a single unique value. That means we'll start from 1 and ends at something. Let's say I have 1000 words. Okay, so there will be some word represented by 1, some word represented by 2, some 7, 8, 9, 3, 5, 3, 3, 2, 1, and some word will be represented by 1000 as well, because we have 1000 total words, right? So in this way, we are giving higher weightage to some of the words. Forcefully we are giving higher weightage to some of the words and giving lesser weightage to some of the words. Okay, before starting the training, even the training is not started, even the machine had not started learning, but still we had given forcefully very high weightage to some of the word. If some of the word we are calling it 1000, we are giving it a higher weightage. If some of the word we are calling 1, we are giving it a lower weightage. So that will create a biasness in the learning. Okay, so integer encoding is fine. Integer encoding is doing what? Is basically converting into integer value. These integer value, this is how we can use for the learning process. This is good for the small size data, but as the data size increases, the weights that we have is not enough. And second problem, some of the words will get a very high numerical value, 1000 or 10,000 or 5,000. That will create the biasness, right? And thereafter, if we are working with 1000 words or 10,000 words, that means here I require 10,000 input neurons. Okay, here what I required 10,000 input neurons. Understood? Here I have 7 input neurons. Why? Because I am working with 7 unique words. If I am working with 10,000 unique words, that means I require 10,000 input neurons. So it's unnecessarily we are using a very huge model, right? So we have to control this thing. So to control this thing, we come across with the process that is called word embedding. Word embedding. So from word encoding, we are moving towards word embedding. Now what is word embedding? Again, so to understand this thing, let's say I have a word over here, AI is dangerous. AI is dangerous, right? These are the unique words. Next we have AI is good. unregulated, dangerous for society. Okay. Okay. AI is good. These are unique words. Unregulated, dangerous for society. Alright. So now this will be given 1, 2, 3, 4, 5, 6, 7. So this thing we already did earlier. What is new? The new is now it will be converted into one hot encoding. 3, 4, 5, 6, 7. Why 7? Because there are 7 unique words. Okay. So we are just converting them into the one hot encoding. This is called one hot encoding. In each vector, only one of them is 1, rest all are 0. Okay. Only one of them is 1. Rest all are what? 0 over here. Right? So now, it's like we have, this is called one hot encoding. Now, how one hot encoding will solve my problem? Okay. With the help of one hot encoding, actually what we do, we will convert each word into a vector. Okay. This is how each word is converted into a vector. Okay. Each word is converted into a vector. All right. Now, what we do, we take this vector over here as an input vector. Okay, let's say for the first word. 3, 4, 5, 6, 7. What is first word? First word is AI. So AI is represented by this particular arrangement, right? AI is represented by 1, 0, 0, 0, 0, 0, 0, 0, like this. This is the representation of AI. So 7 numeric value will go to 7 input neurons. Then we decide over here the output neuron. Alright. So now this output neuron will be connected to this guy. Okay. Right. Same way this will be connected over here. Okay. And this will be connected over here. Alright. Now what happened? We will, here only one value is 1. Rest all neuron is having value 0. Right. That means in this whole set of weights, only 3 weights are effective. The weights which are connected to this neuron. Okay. That means let's say this weight is having a value. This weight is having a value 0.1. This is having 0.2. This is having 0.3. Right. So this will get a value at 0.1. This will get a value 0.2. This will get a value 0.3. That means AI will be represented by 0.1, 0.2 and 0.3. Next word is what? Is. Okay. Next word is what? Is. Right. So now when is will be used. Is having what? 0, 1, 0, 0, 0, 0, 0, 0. Now for the is, only those weights are useful which are connected to this neuron. Okay. Any weight, because this is having a value 0 now. So whatever weight over here present, that will remain ineffective. Whatever the weights connected to this neuron, that will be effective. Okay. So now these weights will get some other random values, right? So let's say here it is 0.2, 0.3, 0.5. Right. So is will be represented by 0.2, 0.3 and 0.5. Okay. Now good. Okay. So for the good we have 0, 0, 1, 0, 0, 0, 0, 0. So here this one will be effective now. Whatever the weight connected with it. So now good may be represented by some of the vector 0.1, 0.6, 0.7. Okay. In this way each word will get a vector. Each word, instead of a single numeric value, will now be converted into a set of vector. This is called word embedding. Embedding means what? Converting the words into the set of vector. Why I should convert into a set of vectors? Because if I use a single value, the number of trainable parameters that my model will learn will be lesser. Okay, if I just use single numeric value, the number of trainable parameters that my model will learn at the end will be lesser. Okay, but if I represent my word with a vector, okay, if I represent my all the words with a vector like this, okay, in that case I can train a model which can learn more trainable parameters, more number of weights. Because to understand AI, now my model requires at least 3 weights. Okay, to learn about is, my model requires at least 3 weights. To learn about good, my model will require at least 3 weights. Right? So this we can control 3, 5, 7, 9, 8, 2, 12, whatever. I can decide that what should be the size of the vector. Like GPT. GPT uses 342. Each word is represented by a vector of size 342. GPT basically converts the words into numeric form. So when it converts the words into numeric form, so it uses a vector of size 342. There is a vector of size 342 to represent each word, whatever the word that GPT knows. I'll show you that thing as well practically. Right? So we are converting each word into a vector, and that vectorization is called what? Word embedding. Okay, this vectorization is called what? Word embedding. All right. So now if I have to do this thing practically, I'll show you how can you do it practically. All right. So let's do it. Let's finish this thing. So we already had converted into a sequence of numeric values, right? So now we just required one more thing, that is called one-hot encoding. So from Keras.utils import to categorical. Okay, right, and thereafter we'll just feed over here to categorical, and what I feed, this padded sequence. Okay, so what are we getting? This is something we are getting that I told you over here. This is one-hot encoding, right? If you see, what are we getting over here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Why total 14? Because if you count over here, we have how many digits? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, something is wrong. Sorry. Let me correct it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? So total 13, 1 to 13 is there, okay, and 1 0 is also added as a padding. That's why this guy is what? We have 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? Because if you see when I converted it, yeah, like when I converted it, I have how many words? 1, 2, 3, 4, 5, 6, 7 words. So 7 words, that's why 1, 2, 3, 4, 5, 6, 7. Because first time this is 1, then this is 1, then this is 1, then this is 1, this is 1, this is 1, then this is 1. Every time that 1 keeps shifting, right? So that's why it is, if I have 7 unique words, 7, but here we have 13 unique words, but 1 geo is also there. That's why 14. So each word, like the first word is what? First is 0. So 0 is represented by 1 0 0 0 0. So 3 zeros are there, right? Like this. Thereafter, I have 3. So 3 will be represented by what? 3 will be represented by 0, 1, 2, 3. And then again all 0. Okay. That's why if you see over here, this is 1, rest all are 0. Right. Thereafter, I have again 1. So 1 is represented like this. This is a representation of 1. Then I have 5. So, 2. This is a representation of 2. This is a representation of 4. So this is representing your first sentence. And this is representing your second sentence. And this is representing your third sentence. Alright. So one-hot encoding is done. Next, I have to convert it into vector. Okay. So for converting into vector, we will perform over here Keras embedding. Okay. So from TensorFlow dot Keras import models comma layers. Okay, these two things I am importing, right? So Keras is what? Is a library which will help us in performing the embedding. Two things are we are using over here. One is called models and other is called layers. Okay, models will be used to create this sequential model. This is a sequential model, right? We have first input layer and then output layer, right? So I have to just write over here model is equals to models dot sequential. Okay, it will help us to create a sequential model, and layers will be helpful in adding the layer. Okay, model dot add. Now sequential layer is defined, so I have to add a layer over here. All these layers we have to add. This is called what? Embedding layer. Okay, because it will convert it into word embedding. This is called what? Embedding layer. Right. So layers dot embedding. Okay, layers dot embedding. Right. So embedding, what I have to feed here? I have to feed first the input dimension. Input dimension means what? How many unique words are there? Okay. So I have 13 unique words and 1 0, that means 14. We have 14 unique words. Next thing I have to define output dimension. That means what is the output vector size you want? I want 3. I want each word to be represented by a vector of size 3. Okay, I want each word to be represented by a vector of size 3. Third thing I want to enter, what is a maximum input length? What is a maximum input length? The maximum input length, if you see over here, 1, 2, 3, 4, 5, 6, 7. It is 7. The longest sentence is what? Longest sentence is of 7 characters. Done. Okay. So now it is done. Let me check the summary if it is showing the summary or not. Sometimes it should show the summary, but it is not showing, maybe some library issue. Anyway, now what we do, we'll just compile it. Model.compile. Okay. For compilation, 2 parameters we require. One is called Adam. Adam is an optimizer which will help in doing these all sorts of calculations. Okay, these kind of calculations will be done to calculate the value of output neuron. So so that same words should get the same output. It's not like that. That is also important. Like suppose AI is there. Okay, AI is used in all 3 sentences. So it will get the same value every time, right? So that will be optimizer will be done, and thereafter, okay. Now model dot predict. Okay, here I'll just feed the sequences so that I can get the predicted output, right? So here, let's say this one I can store into this one is not required. Directly I can feed it. Okay, directly I can feed this thing and automatically this guy will convert the things. Okay, this guy will convert the things internally into first this form, and from this form to the, that means when we feed the padded sequence, this padded sequence will be first converted into one hot encoded form by default using this library, using this embedding layer, right? That's why it is asking you input dimension 14, because according to that it will create the one hot encoding and then it will create the output vector. So model.predict padded sequences, right? So if I will run it, let me just store this in word vectors. So now your words will be converted into vectors, and that vectors can be used to train a model. So if you see here, each word is converted into vectors. Okay, the first three are representing 0, that's why they are same. Okay, thereafter we have the sentence. What sentence do we have? What sentence are we using here? Sentence is AI is generative AI is interesting, right? So this is generative, this is AI is interesting. Then next sentence is what? AI, again AI. No, next we have 0. Sorry, next we have 0. Okay, this is I guess 0, this is also 0. Here we got AI. Okay, AI. So if you see the AI over here and AI over here, it's same. All right. So now this is called word embedding. That means word has been converted into the vectors, and those vectors, we can consider as a word embedding. Right. Now if I want the first sentence, so first sentence will be represented by so now first sentence will be represented over here, word vectors, index 0. Okay. So this is your first sentence, dot flatten. Okay. If I do the flattening, it will just represent your single layer, right? So dot flatten. Okay. This is your first sentence. Sentence 1. And what is sentence 1? Sentence 1 is over here. Generative AI is interesting. Right. Same way, we have 2 more sentences are there. Sentence 2 is index 1. Okay. And sentence 3 is what? Index 2. So this is the representation, numeric representation of each sentence. So what we did, we are having a text. This text I have to convert into numerical form. So we did what? We just did the tokenizer. Tokenizer had given a numeric value to each word. Okay. Now those numeric values are arranged over here to form the sequence of the word as a sentence. Once we have this thing arranged, right, we converted them into a one-hot encoding. Why we converted into one-hot encoding? So that we can convert each word into a vector. Why I have to convert into vector? So that our model can learn more about each word. Okay. If I will represent each word just with a numeric value, okay, my model will learn less about that word. Why my model will learn less about that word? Because if there is a word, let's say 1. So 1 is representing, let's say, what it is representing? AI. Okay, suppose 1 is representing AI. So here is 1 used. Okay, that means my model will only learn, 2 weights over here. Okay, here also 1 is used. Here also 1 is used. So my model will learn 2 weights, weight 2 and weight 4. Okay, here weight 4 and here weight 4 is associated with 5. Right. So ultimately my model will learn lesser number of weights about each word, because each word is represented by single value, single number. Single number will be associated with single weight. Single weight means what? Single trainable parameters. Right. So my model will learn less about each word, but I want my model to learn more about each word. Okay. So if I want my model to learn more about each word, I had converted them into the one-hot encoded form. But the problem with the one hot encoded form is what? Here it will, like with one hot encoded input, only few weights will be effective. Other weights will not be effective, right? Because other are associated with neuron whose values are 0. So that's why this architecture we use, so that we can convert each word into a vector. Now when each word is converted into a vector like this, okay, now more weights can be learned by the model. Whenever I use RNN or I use any other neural network or any other architecture, any kind of architecture if I'm using, which is like RNN or transformer or anything in this world, okay, that guy will have, this is a representation of any word. Like suppose AI is represented by this guy, right? So now AI is represented by a vector like this, minus 0.002, minus 0.03. Okay, so now it's like my algorithm or my model, the learning model, will learn at least 3 weights about AI. Will learn at least 3 weights. Okay, we learn these 3 information. That means it will learn more about AI. Okay, if there is lesser number of representation, it will learn lesser about that particular word. So that's the benefit of vectorization. So here we can control actually, right? If I want a dimension 5, I want each word to be represented by a vector of size 5. No problem. Now my each word will be represented by a vector of size 5. I want each word to be represented by a vector of size 4. So now my each word will be represented by a vector of size 4. Okay. Now each word is represented by what? Is represented by a vector of size 4. Right. So this is what we can control. Okay. As I told you, GPT is using 342. For GPT, each word is represented by a vector of size 342, a vector of size 342. Here we are using 4. Right. Now this data we will use later on with any algorithm through which I can train my model. So tomorrow we'll do that. Tomorrow what we do? We will use this data to train a model, our own model, which can do the sentiment analysis. Okay, that means we will not use any pre-built model. Rather, we will create our own model, which can do some sentiment analysis or which can do some sort of, identification of predictions. Meanwhile, go through the things. Okay, if you find anything which is not clear, let me know. Someone is saying something.
Hello.
Yeah, please tell me.
Sir, all is okay, understanding is okay, but what about the programming? Means what is mean by padding and how to write the program? It is difficult to understand.
How to write the program? To see program you have to write. Okay, so just start right. There is only one way of doing this thing is you have to do. Okay, there is no other way. You have to do. When you write the program, you get the errors, you get the difficulty. Then only you try to debug it, right? So there is no such kind of magic I have that that I can
No,
just
not any
so
basic language programming
yeah.
that I want. Any basic language means if you means आप अगर बता सकते हो इसके पीछे का बेसिक क्या है तो मैं वो लर्न कर सकता हूँ. यानी कि अगर सपोज आपने इधर लिखा है कि कौन सी लाइब्रेरी से लाया, राइट, बट उसके बाद में जो टेंसर फ्लो लाइब्रेरी से आपने वो इंपोर्ट किया, राइट, वो पता चल गया है वो सारी.
ठीक है. प्लीज गो अहेड.
हाँ, बट उसके बाद जो आपने प्रोग्रामिंग लिखी ना, तो उसका बेसिक अगर उसका कुछ अगर बेसिक होगा तो वो कहाँ से करना है वो बता सकते हो क्या आप? तो फिर हम वो कर लेगा.
हाँ, ये दिस इज एक्चुअली अ पार्ट ऑफ न्यूरल नेटवर्क. See, if you want to learn it, I can give you some resources. But even you don't learn it, right? आप सपोज ये नहीं सीखते हो, तो भी जनरेटिव एआई में इसका बहुत ज्यादा ऐसा ऐसा नहीं, लाइक इन द जनरेटिव एआई इट इज नॉट दैट मच इम्पोर्टेंट, right? Why I am telling you if it is not important, why am I telling you? I am telling you so that you can, I am just trying to make you understand this particular thing. Okay, this is called vectorization. Here I am not trying to make you learn this thing. I know this is not at all important in the generative AI. In the generative AI, what is important, this thing is very important, which is called word vector. Okay, that is called word vector, because later on you will listen so many, like in generative AI, in agentic AI, these terms that is called word vector, okay, or vector database, okay, vector database. These terms you are going to, or you can say word embedding, okay, these terms you are going to listen a lot of times, okay. If you are learning agentic AI, you are learning generative AI, so these are the very common terms, right? So if you are going to listen these terms, so I just want that you, whenever I am going to use this term in future, that vector database, that is word vector, so there should be a image gets created automatically. आपके दिमाग में अपने एक image create हो जाना चाहिए, right? That if I'm using word vector, then you should know it is, I'm talking about a vector which is representing a word, राइट? मैं चाहता हूँ ये इमेज अपने आप आपके दिमाग में क्रिएट हो जाए कि हाँ, एक वेक्टर होता है जिसके अंदर बहुत सारे नंबर्स होते हैं और वो किसी वर्ड को रिप्रेजेंट करता है, उसे वर्ड वेक्टर कहते हैं।
हमें कौन से वर्ड के लिए कौन सा वेक्टर है, कौन से वर्ड के लिए कौन सा वेक्टर आएगा, ये हमें पता होना चाहिए। जब आप पता
नहीं, ये आपको नहीं पता होना चाहिए, आप ये पता कर भी नहीं सकते हो, क्योंकि देयर आर मिलियंस ऑफ वर्ड्स आर देयर, ठीक है? अभी आप हर एक वर्ड के लिए उसका वेक्टर याद नहीं कर सकते, है ना? और इट्स लाइक एवरीवन इज हैविंग, लाइक सपोज इफ आई एम क्रिएटिंग अ वेक्टर्स, ओके, सो यहाँ पे सिर्फ मैंने हाउ मेनी वर्ड्स आई हैव यूज्ड ओनली 13 वर्ड्स, ठीक है? तो 13 वर्ड्स के लिए ये वेक्टर बना है ना? अभी अगर मैं यहाँ पे 1300 वर्ड यूज करूँ तो ये पूरा वेक्टर चेंज हो जाएगा, ठीक है? तो वेक्टर आपको याद करने की जरूरत नहीं है, आपको सिर्फ इतना पता होना चाहिए कि जो जनरेटिव एआई में जो वर्ड्स आप यूज करते हो, राइट, या तो आप कोई वर्ड इनपुट करते हो या उधर से कुछ आउटपुट आता है, ठीक है? तो बैकएंड में ईच वर्ड इज रिप्रेजेंटेड बाय अ वेक्टर। अब क्वेश्चन ये है कि मुझे ये क्यों पता होना चाहिए कि ईच वर्ड इज रिप्रेजेंटेड बाय अ वेक्टर? हमारा काम तो वैसे भी हो रहा है, ठीक है? आपको ये इसलिए पता होना चाहिए क्योंकि आप आने वाले समय में एक रैग बेस्ड एप्लीकेशन बनाने वाले हो, ठीक है? जिसे कहते हैं रिट्राइवर एग्यूमेंटेड जनरेशन, ठीक है? और रैग बेस्ड एप्लीकेशन के अंदर वेक्टर डेटाबेस इज वेरी इंपॉर्टेंट, राइट? सो इफ यू डोंट हैव एनी आइडिया अबाउट द वेक्टराइजेशन, ठीक है? अभी आपको एक आइडिया लग गया वेक्टराइजेशन का, आपको एक पता चल गया, you know now about the vectorization. What is vectorization? Vectorization is converting the words into vector. This thing you know, right? Now how it is being converted, that is not so important. ये कैसे convert हुआ ये अभी important है ही नहीं, ठीक है? इसलिए आपको इसके बारे में ये कैसे हो रहा है कोडिंग अगर आप सीख रहे हो तो अच्छी बात है, नहीं सीख रहे तो भी important नहीं है, लेकिन फिर भी अगर आप सीख रहे हो, क्योंकि आप AI के फील्ड में, let me complete. You are in the field of AI, so I will recommend you to learn these things, right? These all things, right? I will suggest you. So this is a part of neural network, ठीक है? This is all a part of neural network. ठीक है? और neural network is a part of what? Deep learning. Okay? And deep learning is a subset of what? Machine learning. Right? So you have to start from the machine learning. Once you understand machine learning, then you can understand deep learning. और उसके बाद आप neural network समझोगे, ठीक है? So you have to start from here. This is your first step. Right? So either you should start from here, go to here and learn here. Right? Otherwise, just forget these all things. No need to worry about it. आपको इसके लिए परेशान होने की कोई जरूरत नहीं है. This whole approach was to make you understand what is vector. That's it. सिर्फ इतना था मेरा कि आपको मैं ये समझा दूं कि वेक्टर होता क्या है. Alright?
Okay.
Yeah.
बट इसमें से जो पैडिंग है, एम्बेडेड है, वो उसका कुछ ध्यान देने की भी जरूरत नहीं है ना फिर बाद में?
पैडिंग ये होता है ना, आप पैडिंग ये होता है ना, जैसे फॉर एग्जांपल अभी आपका जो डेटा है, अभी आपके पास लाइक यू हैव अ सेंटेंस राइट, अभी ऑल द सेंटेंस आर नॉट कंटेनिंग इक्वल नंबर ऑफ वर्ड्स, है ना। अभी इसमें क्या है, इसमें 4 वर्ड्स हैं, इसमें कितने 5 वर्ड है, इसमें 6-7 वर्ड है ना। अब आप जब इसको कन्वर्ट करते हैं न्यूमेरिकल फॉर्म में, तो इट इज बीइंग कन्वर्टेड लाइक दिस 3 1 2 4, ये कन्वर्ट हुआ राइट। Okay, it is like converted into this thing 3 1 2 4. Next convert हुआ is what 1 2 5 6 7, ठीक है। Next convert हुआ 8 9 10, sorry, क्या था ये 13 1 12 13 1 12 11 10 9 8, ऐसा convert, right? Now if you see, if I will convert this thing into a table like this, okay, so see up to here it is fine, but from here it becomes unstructured, ठीक है, क्योंकि यहाँ पे तो कोई वैल्यू है नहीं ना, right? There is no value over here. So now if I have to store this data as a tabular data, or if I have to use it for any machine learning purpose, so how can I use it? I can't use it, क्योंकि whenever you are building up any machine learning model, or you are building up any deep learning model, or you are building any neural network model, you have to create architecture, and in that architecture actually you have to define how many features or how many inputs are there, ठीक है। आपको ये पहले से बताना होता है कि आपके पास कितने फीचर्स है, कितने से। यहाँ पे एक मैंने इक्वेशन लिखा ना, तो इस इक्वेशन में मैंने क्या बताया कि इन दिस इक्वेशन आई हैव लाइक, और या फिर यहाँ समझो, ठीक है, यहाँ पे मैंने एक इक्वेशन लिखा, ठीक है। इन दिस इक्वेशन आई हैव यूज्ड x1 and x2. Why? Because I know I am going to use TB expense and social media expense, right, to train a model, है ना। मुझे पता है कि मैं टीवी एक्सपेंस और सोशल मीडिया एक्सपेंस यूज करूंगा जिससे कि मैं मॉडल को ट्रेन करूंगा, फेयर एनफ, लाइक दिस। नाउ एट अ सर्टेन पॉइंट ऑफ टाइम, राइट, टीवी का कोई वैल्यू ही नहीं है, नॉट इवन कोई वैल्यू नहीं, मतलब कि कुछ भी दिया ही नहीं, मतलब मैंने यहाँ पे इंफॉर्मेशन फीड कर दी है लाइक दिस, ओके, लाइक लेट्स से 10, अब मैं यहाँ पे इसको 10 दे रहा हूँ। अब 10 किसका है? 10 is for TV, 10 is for ADU. That is not clear, right? So will you know that thing will this equation will not accept it. It will raise an error. प्रोग्राम क्या करेगा? आपका एरर थ्रो करेगा, ठीक है। प्रोग्राम ये बोलेगा कि आपने मुझे जो इक्वेशन दिया है उस इक्वेशन के अकॉर्डिंग आप वैल्यू नहीं दे रहे हो, आपको यहाँ पे 2 वैल्यू फीड करना है, आप सिर्फ 10 फीड करें, और 10 बिलोंग्स टू टीवी और 10 बिलोंग्स टू रेडियो और 10 बिलोंग्स टू सोशल मीडिया। इट इज नॉट क्लियर, ये बिल्कुल क्लियर नहीं है यहाँ पे। तो इसी वजह से हमें क्या करना होता है, हमें यहाँ पे डिफाइन करना होता है कि हाँ, फर्स्ट वैल्यू इज 0, ओके, दैट मींस इफ कुछ नहीं है तो 0 है, हम डिफाइन करते हैं 0, एंड सेकंड वैल्यू इज 10। जब हम इस तरीके से वैल्यू फीड करते हैं, then my algorithm knows that this belongs to TV and this belongs to social media. Alright, for that purpose only we have to do what? We need padding. Padding is used just to convert your unstructured data into structured data. Okay, it just feels 0 for those places where we don't have any value. ठीक है, जिससे कि बाद में हम उसको आगे प्रोसेस कर सके, क्योंकि मशीन लर्निंग मॉडल ओनली प्रोसेस द स्ट्रक्चर डेटा, है ना। तो इट इज अबाउट कन्वर्टिंग द अनस्ट्रक्चर्ड डेटा इनटू द स्ट्रक्चर्ड डेटा, right? So you know that is a process, but again, as you said, that is the concept you should know. Basically होता क्या है कि when you go for some interview or something, someone you know kind of just want to understand your depth, like what is the depth of your understanding. So they can ask you like how a model actually process the unstructured data, okay. So if sentences of different length, then how a model learns from the sentences of different length. So you can say like that, it is with the help of padding actually first unstructured data converted into structured data, then that structured data converted into embeddings, that is called vectors, and then that vectors are used by the model to learn, ठीक है। अब आपको ये सब नहीं बताना है कि हाँ ये कोई आपसे नहीं पूछेगा कि ये बताओ टेंसरफ्लो डॉट केरास डॉट मॉडल्स, कोई नहीं पूछेगा। बस ज्यादा से ज्यादा यही पूछेगा कि हाँ व्हाट इज वर्ड वेक्टर। सो यू कैन से वर्ड वेक्टर आर द वेक्टर फॉर्म of the word representing, it is just a way of representing each word into a numerical form, okay, which is called word vector. All right.
Right.
So today we will focus on something which is called tokenization. As I told you in last class, we will try to understand the concept of tokenization and the text encoding. Okay, these are two things I'll try to tell you. Now, what is tokenization? I told you in last class, tokenization is all about splitting the sentences into smaller units. Okay, and those are called what? Tokens. Right? That is the purpose of it. Like for example, I told you, if I have a sentence, AI is future. Okay. Jyoti, you want to say something? Can you hear me? Everyone can hear me?
Yeah, hi, am I audible?
You are audible. Please go ahead.
Actually, having one question, like from the previous session. So
Alright.
it's like yesterday in that transformer you have shown, no, like we can generate the multiple output.